The stars in the Australian flag are unusual because they have 7 points. I became interested in where they came from, and this led me into a small investigation into the connections between these stars, a little bit of geometry, and eventually connections between that geometry and art. So this video explores what those connections are like. To start off with, let's have a look at the geometric origins. The 7-pointed stars featured in the Australian flag, they're based on the heptagon, which sometimes also is called a septagon. Technically speaking, it's the second stellation of a heptagon. A stellation of a polygon is a figure formed by extending the sides of the polygon that can meet at a point. The first stellation of a heptagon produces a 7-pointed star like the one shown here. Now this stellation isn't the Australian flag's heptagonal star, but it's one that does have its own cultural significances. It appears in several flags and emblems, such as the emblem of Samarkand, the eastern band of the Cherokee Nation, a coat of arms symbol for Thun in Switzerland, and the California Highway Patrol badge. The second stellation of the heptagon does produce our Australian flag's 7-pointed star. The second stellation star also has cultural significances, and including those beyond its presence in the Australian flag. Contemporary examples include the Game of Thrones and also several corporate logos like the one illustrated here. As many of you would know, the initial Australian flag design included only one 7-pointed star, and it wasn't the Commonwealth star. It was along with 9, 8, 6, and 5-pointed stars in the Southern Cross constellation to reflect the relative brightness in that constellation. The Commonwealth star itself had just 6 points to represent the 6 states. In 1903, the design approved by King Edward VII had 4 of the constellation stars 7-pointed, and the modern design was approved in 1908, with the Commonwealth star's 7-point representing all of the territories. Game of Thrones fans will know that both the first and second stellation stars feature in the faith of the 7. The 7 points represent 7 aspects of the deity in the faith: father, mother, warrior, maiden, smith, crone, and stranger. If we combine the first and second stellations, this creates what's called the heptagram. Many of you may be familiar with the pentagram. Well, the heptagram is the 7-sided version of that. And again, we can see contemporary examples from the Game of Thrones. However, the heptagram also is significant in several cultures dating back to antiquity. For instance, the 7 days of the week, also known as the 7 classical planets that could be observed before the invention of telescopes, they're all associated with the heptagram. These were pre-Copernican definitions of the planet, so the sun and the moon were included. For an even earlier example, a 7-petaled flower was the emblem of Seshat, the Egyptian goddess of wisdom, knowledge, and writing. Well, how would we go about actually drawing one of these? The 7-pointed star is not easy to draw from scratch. And that's because the regular heptagon is the polygon with the smallest number of sides, the fewest number of sides that cannot be constructed with a compass and a straight edge alone. Instead, it requires what's called a neusis construction. Some people would say a noesis construction, but I'll say neusis, using a compass and a straight edge with one mark on it. Francois Viète produced the first known neusis construction of the heptagon in 1593, and many versions have been produced since then. So let's have a look at a modern construction. We start by using a marked straight edge to draw the line segment QR. The length of that segment is determined by the mark on the straight edge, and it also determines the length of the heptagon side eventually. The second step is to use a compass to draw a perpendicular line descending to and bisecting QR. Then use the straight edge and compass to complete the three remaining sides of the square OPQR. Then we use a compass to draw an arc, as shown here, descending from Q with O as its origin. And then finally, we pivot the marked straight edge around point P up in the upper left-hand corner of the square to find points A and B that intersect where the line segment intersects the vertical line and the arc. That segment AB forms the side of a regular heptagon. And recall that the length of AB is the same as the length of QR that was guaranteed by the mark on the straight edge. A second side can then be constructed by using the straight edge to draw the line through from A through O. And thereafter, the remaining sides can all be drawn just using a straight edge and compass. Fortunately, these days, we have software that will draw a regular heptagon in one step, so we don't have to go through all of this. Now, Anusa's construction of the heptagon actually was celebrated in an artwork, and it was created by a fellow who went by Crockett Johnson in 1973. Crockett Johnson was the pen name of an American cartoonist and children's book illustrator. His name was David Johnson Leisk. He's best known for the comic strip Barnaby, which ran for a decade from 1942 to 52, and the Harold series of books featured a child named Harold who had a purple crayon with which he drew his world and got himself into and out of scapes using a purple crayon for that. Note that Crockett Johnson's heptagon construction was constructed in the last couple of years of his life, and in fact during the last decade of his life, Johnson developed an interest in mathematics, and he produced a series over 100 paintings inspired by and or illustrating various geometric principles and theorems. Some 80 of these actually are archived in the Smithsonian Institution, which has nothing, by the way, to do with me. And at least 2 of these paintings were about his heptagon construction. So here's Johnson's original construction diagram over on the left, and one of his paintings celebrating it is over on the right. We can see that it involves a line segment and a vertical line like the modern construction we've seen, but it differs from that construction in a number of ways. It takes a little bit longer to do than the modern construction I showed you, but nonetheless, it's got its own style and elegance. I noticed that another larger heptagon is actually hidden in Johnson's construction once it's been completed. I don't know if he ever noticed that or not, but I've never seen it referred to. So my diagram here on the left includes that additional heptagon, which is inscribed inside the red circle. And, well, why not? Here's a digital painting to celebrate it. So, what artistic possibilities does the heptagon and its stellations offer? Well, let's consider using it just for tiling the plane. Heptagons can't tile the plane as triangles, squares, and hexagons do, but some parts of the heptagon can do this. So here's a fish scale-like pattern made from a kite shape that's found in the first stellation of the heptagon. So you can see this pattern could be extended in all directions as far as we want. And although it's a very simple pattern, it has a kind of an interest to it because the odd sort of angles that the kite shape forms, which are based on the interior angles in the heptagon and its stellation. Allowing tiling with gaps between the heptagons can produce some attractive patterns. I've produced an example here. So these are heptagons packed fairly closely to each other with little gaps interspersed among them. It forms a regular pattern, and again, this pattern can be extended over the as far out in all directions as we want. Likewise, allowing tiling with overlapping heptagons can produce some interesting patterns too. Here are a couple of examples that involve the heptagon and its first stellation. Well, can we make any art out of this? Possibly. Here's a digital creation I made using that first heptagon pattern that I showed you, with the heptagons tiling the plane with gaps in between them. And here's a more complex creation with heptagons overlapping and stellations, not only the first but also the second stellations being involved. There seems to be some potential for generating these sorts of things. In fact, I would say that the possibilities really are limitless. They're just limited only by the artistic imagination. And that's about it from me. Thanks for listening.